All right, hello everybody. We're going to go ahead and get started here. We're going to be working on part 2 of tectonic plates, taking this idea of the main layers of the Earth that we talked about today, convection cells, which we talked about, and how it plays a huge role in the shape of our continents and the location of our oceans. So I'm going to show a quick video here. I'm going to turn the audio off real fast. Oh, it's already off, cool. And this video does a really great job of showing some of the concepts we talked about in class. So here, the center ball that we have here, this is our core. If you remember, we said that the core serves as our heat source for our planet. So as that heat warms up that lower mantle, this is going to cause convection cells to form. So this partially melts and loses density, causing it to rise. And then as it gets closer to the crust or the lithosphere, it's going to cool down and start to sink again, forming these large convection cells. So you can see the rising here and then the sinking over here. Now you'll notice as this convection cell is going, due to the rigid nature of these rocks, any lithosphere that is above it is going to be dragged along as well. So you can see these sections of crust being pulled away or pulled under each other. Okay, so got that convection cycle and it's just looping over and over. Now this is not a short process. You're talking about millions of years going on here in order to get plates to move any type of significant amount. So we just have these large convection cycles. Okay, so let's look a little bit more at what the consequences of these are and how we recognize these around the world. So the crust, in order to understand plate tectonics, we need to talk about the crust a little bit more. Essentially comes in two different types or two different components. You have continental and you have oceanic. Continental crust is any land above sea level. So here we have continental crust. You can see how much higher this crust goes than oceanic crust here. And it's largely made up of quartz and silica. So some of those lighter materials, if I go back here, some of those lighter materials that we talked about in the last lecture, a lot of granite in that continental. And we'll work with these materials on Wednesday this week. And then the oceanic crust is going to be largely made up of denser materials like magnesium, aluminums, and irons. Okay. Now, the density of these two plates is going to play a really big role in determining which plate is going to go back into the mantle and which plate is going to stay above. Now, in order to have plate tectonics, you have to have plates. So the crust, we mostly think of it as one solid piece around the world, but that's actually not the case. Due to the fact that the crust is very thin and very cold and very rigid, that makes it very brittle, very easy to break. So if you were to kind of zoom out and be able to flatten the Earth into a 2D model, and then strip away all of the ocean waters, you would see these large stitches that exist throughout the Earth. And they are ridges where the crust is literally broken. So broken into these large segments. Okay. So the crust is not one solid piece. It's not like a plate that you would eat dinner off of. Instead, if you drop that plate and you had all those pieces scattered, that is more what our crust is like. A bunch of really small pieces crammed together to make a kind of mosaic of what our crust is. Now, any place where two plates meet, so like you have this Pacific plate and this North American plate, any place that two plates meet, that is going to be referred to as a plate boundary. And this is where most of our interactions are going to occur, most of our natural disasters, and most of our landforms as well. Now, these plate boundaries can happen in three major ways. You can have plates that pull away from each other. So here's our convection cell in the mantle. So if the convection cells are going in opposite directions, well, that's going to pull the plates away from each other. You can have plates that go towards each other. So in here, we have a convection cell and another one that push towards each other. So two plates are going to be pushed together. Or if you had convection cells, and this is a little weird because you're going to imagine it in a three-dimensional sense. So imagine, the convection cell is going this way and this convection cell is going that way. Well, then the plates can slide past each other. Now we have names for these. If plates are moved away, we call them divergent. Plates are moved towards each other, that is convergent. And if they slide past each other, we refer to that as transform. Now, when we talk about convergent plate boundaries, so plate boundaries in which two plates are pushed together, there are three ways that you can have a convergent plate boundary. You can have it where two continental crusts meet. So for example, if you look at India as part of this plate and Asia as part of this plate, these two are being pushed together, and this is the plate boundary that exists between them. So you have two continental sections being pushed towards each other. You can have continental oceanic, where one plate is continental crust while the other one is oceanic, but they're being pushed towards each other. Or you can have oceanic, and that is where two oceanic plates are being pushed together. So like the Asia plate here and the Philippine plate here, you can see this right here. This is a convergent between the two oceanic. Now, each of these are going to have unique landforms depending on what type of crust is a part of the plate boundary. If the convergent plate boundary is continental and oceanic, you are going to have a volcanic arc form. The reason this forms is because the oceanic crust is going to sink underneath the continental crust. Now, as it sinks into the mantle, some of that crust is going to melt. And when it melts, it loses density and then flows up and makes some volcanic arcs that we see here. So one of the telltale signs of a plate boundary existing is volcanoes. Next, if you have two continental crusts, they're going to push against each other and both are going to rise in the air and form non-volcanic mountain chains. A really good example of this is the Himalayas between India and Asia. And then the last one is oceanic. In this one of the plates will sink underneath. Again, it sinks into the mantle, so it melts, loses density and rises, and you're going to form volcanic islands. So similar to like Japan, for instance. Okay. Now, why oceanic crust sinks and why continental crust doesn't sink, we will talk about in class on Wednesday, and we'll do a lab about it, and it'll make more sense. So here are some of the landforms and natural disasters that appear at each of these different types of plate boundaries. Please make sure you get them down in your notes. And again, we're going to work with these a lot more in class as we go forward. Okay. You'll also notice that there are some natural disasters that occur at these. In order to get these plates to move past each other, there's a lot of force that is involved. And a good metaphor for how it works is kind of like a slingshot, where it slowly builds up pressure over time, and eventually it just snaps. And that snap and release of energy between two plates trying to move past each other, that is what we register as an earthquake. All right, next we have divergent boundaries. There's only one type of divergent boundary. This is where plates move away from each other. So you can actually see a divergent plate boundary here of the Mid-Atlantic Ridge. So you can see that stitch I was talking about earlier in the Earth. And here, the two sides of the Atlantic Ocean are being pulled away from each other. And then on this ridge, when those two plates are moved away, mantle is going to work its way up and form new ocean at this plate boundary. So the newest ocean is going to be here, and the oldest ocean is out here, because new ocean is created at divergent plate boundaries. Now, some of the natural disasters that you see here will include things like earthquakes, and you get some underwater volcanoes, which we don't really get impacted by too much with. Iceland is actually a consequence of underwater volcanoes, but for the most part, we don't interact with them too much. These earthquakes, on the other hand, can be quite devastating because they are what creates tsunamis, and we'll talk about tsunamis a little bit later. And then finally, you have transform boundaries. And in transform boundaries, this is where two plates move past each other. Landforms, you don't really get too many landforms except for fault lines, so like areas where the land has completely shifted direction. So you get these large cracks or whatever in the earth. But then also you can get a lot of earthquakes. California is on a transform fault line, which is why they get so many earthquakes throughout the year. All right, so that's where we're going to leave it for today. Here's your FRQ question. Number 1 says, identify the landforms that form a continental oceanic convergent plate boundary. Describe why oceanic crust subducts underneath continental crust. But actually what I'm going to have you do for this one is just write the question but leave it blank. And then I'm going to have you answer it at the end of the lab on Wednesday. And then number 3 says, explain why volcanoes form at convergent plate boundaries. Okay? All right, so these are your 3 questions. Make sure you get them done by Wednesday, and I will see you then.